So number 7 is another solve by graphing, like the previous page, I think it was 3 and 4. Again, I'd factor out the negative and then see if I can factor that, find my y-intercept. It would be a dashed line and go from there. If I can't factor it, I probably would do quadratic formula versus completing the square because of that coefficient of 2 once you factor out the negative. What I really just want to show on this last page is just some other scenarios that sometimes come into play. So the first one here, if I were to solve and graph this, it would look like this. And notice that it has one root there at +1. So the solution set for where it would be greater than 0, every point here is greater than 0. So that would be your all real numbers, okay, if you include that boundary point there. Now, what happens if the original inequality was different? What if it was less than 2x plus 3? Well, when I set that equal to 0, I'd get x minus 1 squared is less than 0. So if you look at this graph here, where are the values less than 0? So where would they be over here? Nowhere. So it would be no solution because there are no values in this quadratic that are going to be less than 0. If we did the other one, where is it equal to 0? Well, where is it equal to 0? In that one spot where it would be actually +1. This second one here, it has the quadratic greater than or equal to 0. So greater than or equal to 0, where is it greater than or equal to 0? It is not anywhere, so that would be no solution. You can do the empty set builder or the no solution, empty set. What if it said, where is this quadratic less than or equal to 0? Well, it's less than or equal to 0 everywhere, so that would be all real numbers, and you could write that again as all real. Oops. Or you can use the x such that x belongs to the set of real. These come up every once in a while. I just wanted to give you examples without having to graph them all so you can see that sometimes you have no solutions or all real, or even just one solution that works if it's equal to 0.